Hello dear students, welcome to DAV Model Public School. I hope you are doing great with the concept of sound. This is the third video of this chapter. Previously we have studied about sound, how are they produced, different types of waves, transverse wave, longitudinal wave. Again we have studied about certain characteristics of wave, wherein we have studied about amplitude, wavelength. These are the certain parameters we have already discussed. So some more things related to this chapter have been introduced in this video. So let's go for it. So some more characteristics of sound. First one, that is pitch. Now what exactly do you mean by pitch? It is the sensation of frequency of the emitted sound. So if an object is emitting sound, so the frequency, what is frequency? Number of waves which is generated in 1 unit of time. So if we calculate the frequency of the emitted sound, we can we can get pitch. So what exactly pitch is? It is simply we have to calculate frequency. What is how to calculate frequency? It is number of wave which is generated per unit of time. So if we calculate frequency, those frequency are, we will find or are of certain nature. So if that frequency would be of either this sort of thing, where this sort of wave would be generated. As you can see, this wave is generated. As you can see, compression, refraction, there is a gap. As you can see, this wave and this waves are certain, you will find certain difference in it. As you can see, there is this wide range. So that is nothing but a low pitch sound. Whenever an object is emitting and the frequency which have been generated over here, so this is a low pitch sound. So low pitch sound, the waves look like this, whereas for a high pitch sound, the waves are very much compact. Here the waves are very apart with the other wave, whereas over here waves are very much compact. So the compact wave over here are high pitch sound. So how to relate high pitch sound or a low pitch sound in normal day-to-day applications? So how to find pitch? It is simply number of waves per unit time. You will either find this type of wave or either this type of wave. If this type of wave is generated, if since you are comparing, so either this and this sort of wave would be there. So that if this sort of wave is there, it would be low pitch sound, wherein here the waves are apart from other wave. So high pitch sound, it is also known as shrill sound. So this is high pitch sound, which is a shrill sound. Example, that is hummingbird. Hummingbird voice is a high pitch sound. Sound of a guitar is again a high pitch sound. Whenever a sound vibrates, whenever a guitar is being whenever a guitar is being it is given a sound, so that whenever the sound which is traveling in air, that sound will travel in this manner. So sound exerted by guitar is high pitch sound, where the waves will travel in this manner. Whereas low pitch sound are those, as you can see, this is a low pitch sound. Low pitch sound. So perfect example would be low pitch sound, also known as harsh sound. Harsh sound means horn of a lion, car horn. Whenever the car is horning, this type of wave would be generated. So which is nothing but a whenever horn car is whenever a person is horning a car, so that this wave would be generated. That is nothing but a low pitch sound. Whenever a roar of a lion is there, which is a low pitch sound. I hope you have understood pitch. Now the second thing, that is loudness or a softness of a sound. Again, how to calculate loudness or softness of a sound? Again, you have to calculate frequency. Again, this type of frequency would be calculated. How to calculate frequency? Number of wave that generated per unit of time. So again, if we consider again this type of wave would be there. Now if the amplitude, now previously I told what exactly the amplitude. If this is the mean distance, the middle line is there, that is the mean position of wave. So So the amplitude is this portion is compression, whereas this one is rarefaction. So if we measure the distance of the exact compression to the mean position, you will get a certain distance. That distance is nothing but amplitude. Previously we have studied, if the amplitude is more, which means it is a loud sound. As you can see here, the distance from main position till the bottommost position of this wave, distance is more. So this is a loud sound. Whereas as you can see, this line is there, that is the main position of wave. And as you can see, this compression portion, there is a very less distance between main position till the topmost position of this wave. So which is, whenever amplitude is less, which means it is a soft sound, whereas when amplitude is more, it is loud sound. Now third characteristics of wave, that is intensity. This intensity of a sound is simply means how intense the sound is. You will understand how exactly this intensity of sound is in future classes. We will derive these equations also. So in short, intensity is basically a sound energy which is transferred per unit area. Per unit area is there whenever a sound is being transferred from one medium to other. So a certain area would be there. So and whenever the striking is happening between two types of wave, certain area would be there. That area which is covered would be multiplied with certain duration of time. You will get intensity. You will understand this concept in higher classes more profoundly. For time being, you have to simply remember this intensity. It is nothing but a sound energy. What sort of sound energy? Upon time into area. That is intensity. Now, timbre. What exactly do you mean by timbre? Another characteristics of a sound, that is timbre. And basically the timbre, it is associated in music words. So timbre, it is pronounced as timbre, describes the quality or the character of a sound. What sort of quality of a sound is, or what sort of voice is this? We can judge, we can discriminate between girl sound and a boy sound. So that is nothing but a timbre. We can differentiate. So the quality or the character of a sound is known as timbre. Timbre helps your ears to distinguish one type of sound produced from the another. So whenever we can even distinguish between the sound of cat and sound of a dog, barking of a dog and cat sound we can also hear. So that is nothing but a timbre. So, the difference of sound which we can recognize, that is timbre. It is also referred to the tone color or the tone quality. Whenever we are talking about sound, it will either be timbre, it will be called as timbre, tone color, or quality, which is nothing but quality or the character of a sound. Since we can judge differentiate between girl sound, boy sound, if a girl is talking, we can differentiate that her voice is of girl, where in a similar way, if a boy is talking, we can differentiate that this voice is of boy. So since we are able to differentiate, which means we can judge quality of a sound, that means we are judging timbre. Now let us see some more things about speed of sound in different medium. Now, as you know, the speed of sound always requires medium for propagation. Sound cannot travel in vacuum, so it always and always requires medium. So sound travel at different speed in different medium. As we know, we basically encounter with three types of medium, that is solid, liquid, and gaseous. So so these sound travel at different speed in different medium. The behavior of sound in solid material would be different. Behavior of sound in liquid would be different. Behavior of sound in gaseous would be different. So speed of sound is different in different medium. So it depends upon certain things. Nature of medium, what sort of nature is there, whether it is solid, liquid, or gaseous. Temperature, on what is the atmospheric temperature, or what is the temperature where the sound is being heard. So temperature also plays a vital role. And pressure is nothing but force upon area. How much intensity, how much force is there, how much area is being covered in that zone, that is pressure. Pressure we have discussed in previous chapter. Pressure is denoted by P. It is nothing but force upon area. So here we are talking about pressure. So pressure would be whenever solid sound is being transferred from one place to another place, the pressure would be there. So the striking point, so the pressure difference would be there whenever particle is moving from one point to another. So pressure difference would be there. So pressure, how to calculate? Force upon area. So the nature of the sound would change. Again, if there is a variation in temperature, particle will travel in different medium, different motion or different nature. So temperature, because of the temperature variation, particle motion will differ, so the quality of sound will differ. So the speed of sound, that is 334 meter per second. Approximate value of a speed of a sound is 334 meter per second. It depends upon nature of medium, that is solid, liquid or gaseous, temperature and pressure. Now, as you can see, solid objects are more compact. Here the molecules are closely compact with each other, whereas in liquid it is less compact as compared to solid, and in gaseous the molecules are very much apart from each other. They are at certain distance. So speed of sound is always very fast in solid substance. The speed travels very fastest. In liquid it is less faster than solid, and in gaseous it is least among the three cases. So speed of sound increases from right to left. As you can see, this is my right. I am increasing my speed from, if there is a gaseous substance, my speed of light would be somewhat less. When the speed of sound is traveling from gaseous to liquid, the sound will travel faster, and when speed of travel is traveling in solid material, it will travel fastest. So speed of sound is moving from gaseous to solid. So the maximum speed of an object would be of solid, not of gaseous. So speed of sound is fastest in solid medium, then in liquid, and then in gaseous. Now, as you can see in this picture, certain mediums are given: air at 20 degrees Celsius, 0 degrees Celsius, 20 degrees Celsius, oxygen, helium. Certain elements are given over here. So the speed of sound will change according to different elements and different medium. Again, different elements are there. So the speed of sound is getting varied over here. For solid substance, as you can see, for solid substance like aluminium at 20 degrees Celsius, the velocity speed of sound is 5700. Whereas in copper, it is 3500, 3560. So as you can see, in solid, the velocity of a sound is fastest. In gaseous, it is least. It is traveling at a very fast 5700 meter per second. It is tremendously fast. Here it is 331 meter per second. So it is very less compared to that of solid. In liquid it is 1493. So from this chart you will come to know that speed of sound is fastest in solid, then in liquid, and then in gaseous. Certain solid examples are given over here, certain liquid examples, and certain gaseous. These values are found out experimentally. So you simply have to remember, you don't have to remember all these values. It need not be helpful for your exams and all. You have to simply remember that velocity of a sound in air, it is at 20 degrees Celsius, or at normal temperature it is 343 meter per second. This value will help you out in solving numericals. Other values are not so important. Now we will see reflections of sound in the next video. Since this video will get lengthy, so in order to avoid the quality of sound or quality of video, we are skipping over here, and I will proceed with the next video, and from here I will start with the next video. Thank you.